everyone, and today we're gonna start with Linux and OS systems. Okay, so we already discussed before you study anything. I mean anything. It's not about this. Anything. You should know three answers. What, why, and how. Sorry, not before, but you should know what we are studying, why we are studying it, and how we're gonna study it. This can become later, but this you should know. So what we are studying here, we are studying a Linux system. So what is Linux? We already discussed that Linux has a system. It's an OS system. OS means operating system. Operating system, what is the operating system? Operating system is actually the system which are the layer which talk between application and hardware. Okay, so what are the layers in between this operating system we will discuss now. So Linux especially, it is built on kernel. So first layer of the Linux is kernel. Let me increase the size of kernel. And the second layer is shell. And the third layer is anyone? Yeah, application. Now, what is kernel? Kernel talks to hardware. Okay, kernel is designed to talk to hardware, and shell is the place where we give our commands. Okay, so this is the part of Linux. We can give command to shell, and shell can talk to kernel, and kernel can talk to hardware. Okay, application is basically the software we use. Okay, so whatever application we are using, let's see, we have VI. Okay, so we are using VI for text editing, and what VI do, VI will talk to shell. It give command to shell, and shell then will talk to kernel. So this is the Linux structure. Okay, you can say this is the Linux structure. Now the next is why. So we are studying this for HPC, and we know what is HPC. HPC is high performance computing. And in high performance computing, you should know one thing. You should have one thing. What is this? Resources should be used wisely. Okay. So Linux is a very lightweight OS. Lightweight means its size is very less. So we can it can use less resources than other operating system. So we will use Linux for one reason. One is other is security purposes. You may have heard of that some of the Linux are used in cyber securities version of Linux like Kali Linux and all. So it is for cyber security type, Linux is performing better than the other OS systems. And how, this we gonna learn in a bit. Okay, so we know what, we know why, and now we will understand how. So before going to anything, let's start our command prompt. Okay, so there is different ways you can. I am using here Windows. If you are using Mac OS, then you can just type here. Okay, you can, Mac OS is built on Linux, so you can um, do your commands in the command prompt. But Windows is not built on Linux. So for Windows we have two options. First, we will download the WSL. For that you have to do nothing. You have to just write install, okay, in your command prompt, and sorry, WSL install. You have to write WSL and install. I already installed, so this will not work, but I can write update. Okay, so it's checking for update. I have most recent version, so it is not. But if you have to install, you can replace this update to install. And when you install, you will see this Ubuntu page in your. So on default, it is in Ubuntu, but you can change your Linux system. Okay, and the second way is to download a virtual machine. A virtual machine is actually something that can second first for this is only for Windows user. First method is WSL, that is Windows subsystem for Linux, and the second method is virtual machines. Okay, so WSL is nothing, just work on your machine. Okay, you also have this folder in Linux folder. Okay, so WSL is nothing, just works. It's a subsystem for Linux. It will work on your Windows. But in virtual machine, you will download a virtual machine. You will share your resources with this virtual machine. Like you have a if 4 GB RAM. Okay, so you will say that 2 GB will give to this virtual machine. What is the problem with that is resources are two different things. Now you have two machine or one system. So that will be a little messy when you have to work on the same file in the different folders. Okay, so through that I can go in any file or folder in my laptop. So I prefer this, but you can also download virtual machines. Okay, in CDAC you mostly download virtual machines. So let's start with, after that everything is same. Okay, so this is your command, first thing you see in your Linux. So you say sneha at the rate hyperx omen colon and then tilde and then dollar sign. So what does that means? Okay, so let's say we see sneha at the rate hyper omen x colon tilde dollar sign. That's what we see. Now what does that mean is this is your username. Okay, this is your host name. This is your address, and from after dollar you can start typing. Okay, so a host can have multiple users. You can make multiple user for a same host, and like you have a Paramutkarsh and all, so it is a host. And if you have given id like user 01, user 02, user 03, that is your user. So you can make multiple users on a same host name with multiple permission as well. You can give multiple permission that this will can edit, this will can only read, and etc. Okay, so this what that means. Okay, so this is your we can say shell. This is where the shell is, and this is where we should start typing to give commands. Okay, so let's learn with the first and very easy command, which is pwd. What is pwd? Pwd is present working directory. Okay, so it will give you where we are operating on right now. So we are in this folder. Okay, and now if you have to change your directory, then we have command like cd. Okay, so cd what? Cd, after cd you can write whichever folder you want to go. Now I want to go to home, then I will click two dots. When you go to previous folder, then you will click two dots and you went to previous folder. Okay, so now you can see this tilde sign is changed to home. Okay, what that mean? That means our address is now changed. Okay, so we learned two commands here. What are the commands? One is pwd, that is present working directory. Okay, and the second command is we learn is cd, and then you will write the folder name. Okay, then this means as change directory. Okay, now we first learn about, also one more command I have to tell you before that, that is ls. What is this? It is a list. So it will list all the files or folders in that folder. So we don't have anything here right now, it's fresh. So we have only our Sneha name folder, so it is Sneha. Okay, so next command we learn is ls, which means list. Okay, so it will list all the files and folders in it. Okay, I hope it is clear till now. Now next thing is to navigation. Okay, before going to further commands and all, I think next topic should be navigation. Navigation you all know, right? Navigation means how to travel in this. So if we have this, and if we press the upper scroll button, then we have the previous command. Okay, and go page up, previous command, page up, previous command. And when you click page down, then it will go next command. So page up means previous command, page down means next command. Okay, so navigation, in navigation we have, if we press page up, it means this arrow key, it will give us previous command. And if we click page down, then it will give us next command. Sorry for the handwriting. Okay, so this is one thing. What is the next? If you want to, like, let's see, if we want to enter in this Sneha folder, then for to change directory, what is the command? cd. Now if it has only one folder, but if you type, I just pressing s, and then after s, if I press tab, it will automatically complete our command. Okay, so if there is a file name and there's a big file name, like big dot file, sorry, not big dot, big dash file name, and then you are not going to type it every time. Okay, so you just type big and then press tab, and it will automatically take whole file name if the similar file name does not exist. Okay, let's see. So for tab, we can say completes command. And there is one other command which I can't show you because it isn't, we are not running anything right now. But if you run a very long commands, and then you see there are some mistakes, then you can press Ctrl C and you can abort that command. Okay, so these are the navigation uh, thing in your Linux: page up, page down, tab, and Control C. Okay, so let's move on to our real thing, that is commands. So we learned 3 commands right now: pwd, cd, ls, and now next is, let's first move in our Sneha folder. Okay, now it's, let's make a new directory. So directory, whenever I say directory, it means new folder. Okay, don't confuse with it. So for new making a new directory on new folder, we have to place mkdir. Okay, and then name it. name, let's say we give you do. Okay, now if we do ls in the Sneha folder, and we have the folder name do. Okay, now we will make a new folder mkdir, let's say on. Okay, so now we do ls, then we have two folders, do on. So now after ls, what will be the command? Let's say we are going into cd. Okay, cd we are going to do. Okay, now we have to make a text file basically. After let's say if we have to text command, we have touch, we will say touch, and we name it like first dot txt. Okay, so we made first dot txt. Okay, so it will, what will it will do, it will make a first dot txt, and we can confirm it by ls. Okay, so our file is made. Now how to edit this file? Okay, so for editing we can just vi first dot txt. Vi is a text editor. Now in vi you have this type of interface. Okay, and you can see here there is a name first dot txt. Okay, it's l and b is line. Okay, and then we haven't written anything in it right now. So to write, if I press any button here, okay, so it will does not give you that, or now there is a visual. Okay, so if we write I, that's the thing, we have to escape it. Okay, now if we write I, now here you can see there's an insert. Okay, there's an insert. So now we can write in it. Now you will type, it can write. Oh, but if you escape from, you can't write now. Okay, no previous regular expression. But if you press I, you will in the insert mode. We will cover all this complicated thing, but first we have to, this is, we will write this is our first Linux text. Okay, this is our first Linux text, and we will escape, we will sorry, we will escape, and we will save and quit. W is for save and Q is for quit. We will we will go through with all of these shortcuts and forms of vi in a in later part. For now you just have to know this. Okay, now first.txt, we made first.txt. Now if we have to print the command in the first.txt, we can just cat, and we type first, and we can press tab, and then we press enter. Okay, so this is our first Linux text. What cat will show you what is written inside this text file. Okay, I think no problem. Now if we come to, this is our basic commands. We learn about present working directory, we learn about change directory, we learn about mkdir, that is make directory, we learn about ls, that is list documents, we learn about touch to make any file, we learn about vi, which is a text editor, and we will learn more about it in the later chapters. Now we learn about cat. Cat is to print the output of any file which you write. Okay, so we learn about those. Now the basic terminologies, basic navigations is completed. Also there is one navigation I forgot to end. If you press enter, that means you're giving the command to run. Okay, now the what is next thing. Okay, What is next thing? Next thing is shell scripting. We already discussed that we talk to shell in Linux directly and shell talk to kernel. Okay, this we already know. So now how we talk to shell, like how what we did here, we talked to shell in this. Like if I write this echo, this is Linux shell scripting. So what it will do, it will act like a print statement. Okay, so echo is for printing. Okay, so this is a Linux shell scripting. Is now if we write echo, okay, today is so we have today is Friday, July 31, 4:45, 31 UTC 2026. Okay, so this is the shell scripting. Echo is word used for print. As you use print in Python, echo is word used for in Linux. Okay, and what other thing you want to um, check is like if you want to do any math thing in this, like say echo 12 plus 5. So we are saying echo 12 plus 5 and sorry. So we just say, okay, so it printed 12 plus 5. Okay, now if we say echo, sorry, we know the shortcuts 12 plus 5. There is a segment of Linux we will discuss later is about pipelines, and this bar is pipeline and then BC is for calculation, math calculation. Now we enter and it gives us 17. So this is how you can do math calculation as well in the shell script. Okay, right now let's try one other math, like echo 12 divided by 6. So we all know 12 divided by 6 as, yeah, 2. So it is BC, it's 2. Okay, but what if we do 13 divided by 2? Now we know it's not it is something we common points, but what did you do? It will not give you point. Okay, so if you want something this, then what will you do? You will write a scale. Okay, so I want to have a scale of 2-point digit. Okay, now you will enter colon. Okay, then you will give 3 divided by 2 and press this pipeline and BC. Okay, now we press enter. Legal character this, let me check. Okay, so is the pointers, here we have this, yeah, now enter. Yeah, so it's is 6.5. So if you have multiple digits, like point digits answer in a point digit, it's not fully divisible, then you have to enter the scale is equals to 2. Okay, and even multiplication, like let's try echo 2.5 into 8. Okay, so we know there's something come with, okay, pipeline BC, and we enter and it give us 2.0. Now if we do the same thing but we add scale in it, scale okay, is equal to, okay, Linux is very case sensitive. That you may know, case sensitive, but Linux also sensitive with spaces. Okay, so if you the space needed but you didn't give it, so it will throw error. Okay, now it's look fine. Let's enter. Sorry, 2.5 is 8.20. 2.20.0. Okay, so this is something we can do a math calculation in eco through eco, and you can even take the power of the thing. Okay, like if we type eco, okay, and we type 10 raised to power 5, okay, and then we close, and then we pipeline, and then we bc, and then sorry, and then we enter, we have this. Okay, so this is, in fragment we learn how to do calculation on the Linux shell. Now we already learn about the pv basic commands, we already learn about the mathematics. Let's make a new file. Let's make a new file named vi. We already have our first document. Okay, so let's do some change in it and to learn some new command. Let sorry, first.txt, and we will enter. Now we can't add it in until we press I. Okay, so vi, this is for first Linux test. Okay, this is first Linux test and this is our second line, and we will to show you the sorting. Okay, so we made this file which has, this is our first Linux text, this is our second line to show you the sorting. Okay, next let's say we will have right, zebra is red in color. Okay, and apple is black and white striped. Apple has black and white stripe. Okay, so let's not make English mistake. Okay, so this is our document. Now we press what, escape button, then we press colon, and then we save, and then we quit, and then we enter. Now we will press the same command, cat first.txt, and we will see the command. Now what will happen if we press tag first.txt? You'll see it just reversed. So you can see there, our last line was apple has black and white stripe, but now it is our first line. Okay, now next is sort first.txt, and what it did, it sort by the alphabetical order. Apple has a black and white stripe, then S, then T, then 2, and then Z. Okay, this is what the, you can easily manipulate your document inside the Linux. Okay, and let's make a new, if you want to make a copy of some document, like copy to of first.txt to second.txt. Okay, so we will enter. Now we will press ls, and we have two files, first.txt and second.txt, which currently is same, right? There is no difference between them. but we can find the difference between them with the grep command, grep. So we will write grep, grep. Okay. Now we will write whatever command we want to find. Like we have to find r. Okay, that's whatever word we want to find in the document. We'll write r. We will name the document name first .txt, and then we see where does the r come. Okay, so next, like we have to find graph, and we have to find second in our text. Where does the second comes? Sorry, it is second, and we have to see where does it come in the first .txt, and we have the line where the second come. Okay, so that's how you can use grep command. Grep is command for using wherever, if you are confused and you want to see where does this word come in the following document, then you can use the grep command. Okay, now the next part is let's see what this command do. Grep ri and your file name. Let's say command is second. Okay, now let's see what happened. So you can see that it will, if you write something like grep ri second, you have a word, and if any file in your folder have this word, it will print it. Like it print that for in first .txt it is come here, and in the second .txt it is come here. Okay, so that's, I think, a very useful thing if you have a long folders too. Now let's move to something else. So this is your basic commands, and there are more many commands like this, and I will give you the list of the commands and what will we do. Like lpr is a command used to print the document, but currently I have no something attached, so it's giving me error also. Okay, it's not installed in there, so maybe it needs installation. Anything you have to install in the Linux, you have to uh, run this sudo command. Actually, sudo is for we will study it later about the sudo commands too. Okay, so this is our some basic commands like pwd, cd. Okay, pw is for present working directory, cd is the change directory, make dir, ls, and cd. Okay, and vi. These are some basic commands. We have echo. Now we will learn about, wait. Okay, so we will learn about some basic commands. Some basic commands were, sorry. Okay, so some basic commands were pwd. Okay, we have cd, we have ls, we have touch. Okay, we have whatever the other command, graph. Okay, we have cp. We learned about copy, how to copy and how to move as well. Let me show you. For move it is mv. Okay, and what you want to do, you have to do the file name and the folder name, like first .txt and where it will go, the folder path. So if we have we are in currently in do folder, but in our do in our sneha folder we have two folder, do and on. So let's paste this file of do into on. So to do to on, first we have to go to previous folder, then from do we have on. Okay, so we have to move it there. So let's say, now let's see ls. We have no file here, we have no first file here. Okay, and where it is, so let's see cd. Now we have cd on now, and print ls, and here it is. Okay, So for move as well, you can use this command. So cp move etc. Okay, so we learn about cp, we about move, okay, we about grab, we learn about echo. Okay, so we learn about these commands, these basic commands. Now what is a shell scripting is far more than typing this just a command here. Shell scripting is, in the shell scripting, as we do conditional statements and loops in our Python, C++, we can do the same here. Like we can use if statements, okay, we can use if, while, okay, okay, and this stop, continue, and for loop, while loop, sorry. Okay, same we, so like Python and others programming language, it is also work on if else. Okay, if else statement are also there, for loops are also there, cases are also there, and while loop are also there. Okay, and we have the conditional statement like and or statements, like, okay, and or. So we all have this, but how we will run this, that's we called shell scripting. Okay, so let's see shell scripting here in the command. Okay, now let's make a new file. We are in move into our folder. Okay, now let's make a file vi, okay, um condition dot sh. Okay, if you ever make a file for shell scripting, you will name it as .sh. Okay, so we have to, first step is to add the shebang, but it will work as well if you don't do. So okay, so first statement is if. Okay, let's say what is your whatever you want to do for. For if statement, what we will do, we have what is the syntax? We will write if, then we have double bracket, or if there's a mathematical thing, we can also use this one. Okay, for this one is we can use this, but if we write this one, we have to write x is greater than. Okay, and also space is very important. Yeah. Greater than, if x is greater than 20,000, let's say, then print, then we have to write here then. Okay, just not then, we have to write there then, and then we write our statement echo, what we all want to print. uh, you have sufficient, no, it's काम चलाओ. Okay, so it's काम चलाओ. What is this x here? So we have to give x first, we have to take x from it. So let's say we have echo, we will print first, and we will ask, dude, what's your salary? Sorry, Baba, sorry. Okay, so we write, dude, what's your salary? We forgot the question mark here. So now for reading that command, like we have scanf and all. So for that we have a read, and we will read x. Okay. So whatever the person will type, user will type, it will save into x. Okay. So if x is smaller than, sorry, smaller than, less than, sorry, in this it is lt, is x is less than 20,000, echo काम चलाओ. Okay. And else, well, it's not 20,000, that's it. Everything is so, now that's look fair. Okay. Else what? Else you can type the statement like echo, and okay, good. Okay. So we will type good. Okay. Now the next thing is we have to add an opposite fi to the end. And let's start running it. Let's see if we have coded it right. Let's wait, there is some mistake. We didn't add a space. And we have to have space here. So esc and this and wq and enter. And then to run this command, we have to write bash. We'll write our, sorry, we have to write bash and then our file name, and then we run. So dude, what's your salary? My salary is very less. What is that? 25,000. Oh, come chalo. Okay, let's try the other one as well. So bash condition.sh, and dude, my salary is 60,000. I'm no good. I don't know how to add emojis in that, but okay. So that's a if and else loop. But what if we want to have multiple if and else commands? Now we have if, then this, and now, sorry, ai to insert, and then we will enter, and we will give our next command. Okay, what is it? It is if, okay, square brackets, and x is less than 30,000, it is kam chalao. For greater than 30,000, let's say, and it is, let's say, then, and echo, okay, okay, जिंदा रहने के लिए जरूरी है. Okay. So now last else, it is no further than let's say equal to. Okay, equal to. If it's equal to, it's right. I write it. Let me check if it's really equal to. It's, I think it's eq, but let me check. So yeah, yeah, you said EQ. So I thought it was ET, but it is EQ. EQ. Okay. So if it's less than 30,000, it's kam chalao. If it's equal to 30,000, it's okay. And else, good. Okay. So we will press escape, WQ, and enter. And now we see if we have any we done any mistakes. Okay, bash, dude, what's your salary? It's 30,000 because we have to check our equal to. That's okay. Okay. So now this what we do. Now one thing else what we do in this file, it's adding and or in this. So every command, you know, there is an conditional statement like and or. So let's say if we have to write elif, and we will write condition like it's less than, sorry, insert, and I always forget about, so we have space. Okay, then we will write this is for and, both the statement will be taken, like if it is equal to 30,000, or let's say less than, x is less than 60,000, then it's okay. Okay, and we have to close the bracket with space. Okay, and okay, and for that we will, if your salary is greater than 30, that we can save मजे आ गए बस. So now it makes sense. Or we can also say, okay, so we can skip, we can, I hope there's no error in this. Yeah, it's look good. Let's check. So we will do bash, and we'll ask, and we will do something like 45,000, which lie between 30,000 and 60,000, and it's okay. And for just for my sake, let's do it again, because I wanted that last statement to be print out to be seen. And yeah, and now we have more than 30,000, 60,000, that is 70,000, let's say, and मजे आ रहे हैं बस. Okay, so this is with our all the changes and all the conditions we can apply in if and else loop. So we let's go through with the file again. Now you can see that first is echo, that means print this, and then it is act as scanf, which is used in C, and then we will write if, and we will write two square bracket, then we have space. Space is very very important in Linux. Okay, the space, then we have our variable and statement condition, and then again space, then square brackets, and then it's syntax. So syntax of the if statement were, syntax of the if statements are, okay, so we have if, okay, then we have our two square brackets, and then we have our condition, then space two square bracket, sorry, then, okay, then we write our whatever the command or condition here, whatever the printing statement, sorry, condition goes here, and statement goes here. Okay, then if we have elif, then we will apply elif, and same two square bracket condition, okay, and then two square bracket, and then wait, and then we have done, and then we are statement, and if you have another elif, you can continue with this loop. Okay, and then we have else, and after else what we have nothing, we have statement, and after statement we will do not forget to write fi. Okay, so this will our bash command for if statements. Okay, Now let's write something for loop. So like the if statement, there is, so like an if statement, there is a for loop as well. And for loop, we will study a new, we will make a new file. Sorry, my keyboard is a little far from here, is that's why I have to. Okay, so wait, so for loop, we will make a new file, pi loop.sh. Okay, yeah. Okay, now what we will type, we will type I to insert. And for loop, what will be true, we will, let's say, write we want to write a number 1 to 10. Okay, so we will start our counter, let x is equal to 0. Okay, now for loop, what we will do, for I, okay, in, for I in, not say, we will need no need of counter here, I think. We will just write for I in, we will write our loop here 1 to 10. Okay, and then we close the bracket, and then we add a colon, and then we write do, and then we write our whatever echo I. Okay, and then we write done. Okay, and let's run it. So we will write bash, and we will write loop, and then it's an unexpected token of this in this line. Okay, there's an error. So we will write our command this, and okay, for I and range, so spaces very mandatory, spaces here, spaces here. Okay, so wait a minute. I think this must be maybe. So let's see if this will work. Oh yeah. So it's not taking loop. Okay, wait a minute. Oh, sorry. So making it 10, it's will be 10, and here we didn't write dollar sign. So like an and percent in C, there is a dollar sign for variable here, which we didn't write. That's why we have this error. Okay, so this WQ, let's write now, and that's dash. Now it's okay. Okay, so this is how you will run the for loop in your Ubuntu or Linux system. Now next is let's take a while loop. What is while loop? I think you may all know what is while loop. It run while the statement is false. Okay, uh, up till the statement is true, it will run, and when the statement is false, it will stop running. And we have then until loop, which is same. Okay, which is different, that it will run until the statement is true, and then when it gets false, it will stop running. So let's make a new while, no, sorry, vi while dot sh. Okay, and this we will run a while loop which will count 1 to 5 and then add in. So let's add a counter which is equal to 1. Sorry to not insert I. Okay, so let's say x is equals to 0. Okay, and okay, now what is while loop? We will write while and we will write space and then bracket and then we'll take x. Okay, now x is, if x is less than what, oh sorry, less than equal to what, let's say 10. If x is less than equal to 10, then what we have to do, space, this we have to complete and colon and do. If x is less than equal to, then do what, echo print x. So, okay, and next is count x plus plus. Okay, so this is the my next and done. Okay, so let's learn. Let's run this and bash loop. For loop we have while tab enter, command not found, less than equal to, less than equal to, not command is not found. That's, let's see. So space means a lot in this and we have a space in this, so it is not recognizable. So let's see now if how does the, okay, so wq enter. Now we will run the command bash while and it prints the count. Okay, so we have this while loop. Now we will try the until loop as well. So what is the difference between while loop, until loop and for loop? Do you know that? So let's make a new file vi which is name is until dot sh. So as I see that bin bash doesn't make any change, we'll write insert, we'll start writing. So until loop actually runs as long as the condition is false, whereas while loop runs as soon as the condition becomes false. Matlab, as soon as the condition is true, like, okay. And so we will write let's say some, we'll have some number and we will have to give until this, run this, if not then stop. So until my salary goes to 30,000, run this. Okay, so escape, duplicate, yeah, it one mistake as well, that is whereas I and so it is salary here. Okay, now let's see working here. Now bash Hey, मजे आ गए अब 20,000 अब 30,000 अब 40,000 अब 50,000. And if we said like we did in the previous original version vi until such, then equal to, let's say we have greater than or equal to g e, and let's say this wq and bash and same output. So this is with our until loop, and here our loops are over. There are also, you can nested loops in for or for j. So this is our practical sections that was over for now. And so we discussed the if statement command. Now let's discuss for for statement. For statement, we have what we have. We will have a for, okay, then we will have a space, and we have our condition, okay, for I n, whatever our in curly bracket, whatever our range, okay, range here, and then we have semicolon, and then we write do, and then in next line we will write our statement, whatever we command or slash command, okay, and then we press then we write done. So this is the syntax for loop. For while loop, on the other hand, what we have, for while loop we will write while, okay, and then we write our condition, while this condition, then we have a semicolon, then do, and whatever the, sorry, whatever be the statement, and then done. Okay, similarly for until loop, we have until, okay, and then we have square bracket condition, then we write this and do, okay, then we write this and do, and then we are statement, condition again, and then do, sorry, done. So this is our 3 loops, okay. Now next we will study about the some theory of the OS system, okay. So OS system is first is process, okay. So for the process, process has, what is the process, okay. So what is process? Any instant of a running program, okay. If there is a program, if you give some task so to CPU to do or GPU to do, or so there will be a process in which this task will take place, okay. There are steps in this task will take place, so this is called the process, okay. So we can say instance of program, or we can say running program. So this is our process, okay. Now every process has some stages or states, we can say. So what every process start with a step with new process, okay. Every process start with a new process, and then it goes to the queue, and it is entered to in the ready state, we can say state or stages of process, okay. So start with new, and then with it enter into the queue, and then it will enter to the ready state. Okay, after ready it will go to either run, or it will either suspend. Sorry. Okay, so there are many tasks that you will do, but laptop, your computer will suspend it before even running. Okay, then we call task manager. So okay, or you can say suspend, or maybe wait or block, or you can say there is the wait. Okay, for new it goes to ready, and ready to it either goes to run, it either goes to suspend, or either goes to waiting line. Okay, so now run program, if program is running and some other program is more prior than it, so it can be either go to wait or it terminate. It run fully at one go and terminate, or it will either go to wait statement and then wait, it will again go to ready and then again go to run and then go to terminate, or this. Okay, like if you write anything, like if I am writing this and then I am erasing it, so these are the command, right? Like we write control C, if you press, command is running, but if you press control C it will abort and then it goes to either wait or either, then it again goes to ready and then again goes to run and then terminate or wait. But if you wait and enter it, then it also goes to suspend. Okay, you abort it, control C, it will go to suspend. So it will, from suspend there's no way to again come to ready. Okay, so this is the chart looks like of the states. First new, then goes to ready, then goes to run, then goes to terminate. Run statement can go to wait, and then wait statement can go to again ready and then go to run or terminate, and the wait statement also go to suspend. Okay, so this one is easy and I hope you understand this. Now if you want to see commands, like if you write here, let's say top. Okay, so you see this. Okay, so this all are the commands. Okay, you write top is the command for mentioning the top processes running in your terminal. So these are all the processes. All processes have some PIID. Okay, program ID. A user who will be the user, the root user. Root user means CPU is running those commands. Okay, it's okay. So the system MD plus these all are CPU processes which is currently going on. So there's a percentage of CPU it is taking, percentage of memory is taking, how much time it is taking, and command, whatever the command which is give. There, see, there also one command that we give, Sneha, and PR is ID is, if you can track this, its ID is 362. Let it go. Okay, Sneha 362. There are PR number is 20, and where does it go? Yeah, there it is. Okay, yeah, there it is, and it is bash, the bash command we just run. So command is bash and user is Sneha and ID is 362. So, and how much time it takes? 0.058 seconds. Okay, so this much, this is the whole your identity of the processes. So you can, if you want to see the then now if I have to abort the command because it's keep on running because CPU is working, so we have to press Control C. Okay, so it will, I think, abort the command, not command. Okay, now so every users have PID, program ID. This is the username, this is the program reference. I don't know what is PR, and what is NI, that I don't know. That is res, I think res, That's, I don't know, but that is a percentage of CPU, percentage of memory, how time it will took, and the command that was entered to run this task. Okay, so one has to be noticed here, that is one sneha 362.406 sneha. Okay, or the command is run by bash and systemd, means we are running this ubuntu here. Okay, and so this looks like, this is the program IDs all we have. Okay, so there are other command which you can uh, if you know the program ID, you can write this command, like to kill any processes. I can't kill the processes right now going because they are CPU processes. So, but to kill any processes, it's, you have to just write dollar, sorry, not dollar, just write kill. Okay, and whatever the PIID. So if you write this statement, it will kill that abort this program, and it will directly send it to work suspend. Okay, so it will, the program will be suspended, and there's no way to get out of the suspend. Okay, so this is your program, how the program, what the program, and what, how it is working. Now there are many types of programs. I think that's I don't know if it's very useful, but let's study. So one is user versus, so there are many types of programs. Okay, so let's say user program, like user program run by user. Okay, so any program that you run, you, like, this is the software which is running, it is an application which is running on the Windows, so this is the user program run by user. Okay, next is system, so run by system. Okay, the command we just see. And there is foreground commands, foreground, sorry, not commands, foreground processes which run on foreground, and there are background processes which run on background, majorly done by CPUs, internal processes. Okay, and there are batch processes. Batch processes is sequentially with little or no user. Batch processes that which you can really say that is background processes. User have no input in that, no user input, run on no user input, but it still run. Okay, it run in the background basically. So it is batch processes, and we have other processes like interactive processes. What is interactive processes? Which, in which user interact. Okay, so user interact, so it is interactive processor, like the command I give with mouse, I giving with the keyboard. It's, so you can understand it like this, that if you editing a video, okay, if you editing a video, you edit a video, like you add some mask, you add some filters on it. Okay, so you are editing a video, you are giving command. Okay, so that is interactive section. But now then, when you edit a video fully, and then you go send it to render, and then this video will convert into mp4 and save in your devices, that is totally a bash command, because you do not have any input or to give there. CPU run this command. Okay, so this type of thing you have real-time processes. Okay, so which run on the real time, immediate execution, like. Okay, then the interesting processes are, one is parent processes. Okay, these are important, I guess. Parent means whatever the main process which is running. Okay, now next is child processes. Child processes has, you, everyone know, run on, it is independent. Okay, and it child processes are the spawned of parent process. Okay, some like parent give this command, and in on the basis of this it divided on two parts. Okay, so this is child processes. uh, it is also run independently of the parent, but with supervision. Okay, now next is zombie process. Zombie process. Zombie, what is zombie? Zombie is there's no one to guide it. Okay, so when the execution of the process is completed but it's still using the computer resources, then it will zombie process. It means execution is completed but still using resources. Okay, so it's like someone died but still using a auto to breathe, and that's not fair. That's zombie. Okay, and other is orphan. So who is orphan? The parents are not there but child is still there. So if we just studied about the parent process and child process, so if parents process is ended but the child process is still running, then this called the orphan process. Okay, so parent process is completed or terminated but child process still running. Next is multi threaded processes and single threaded processes. So this is the most important thing for HPC. HPC is nothing, just a multiple thread we can run on different computing nodes so that the thing is faster. So this is also the same thing that we will for executing a one task. We just don't do it by line wise, we do it by separating it in multiple tasks, multiple smaller tasks. Okay, so same things if multi-thread, even if if you have laptop, you can check it has CPU cores, number of cores. So if your number of cores is 8, then you can run 8 thread. Okay, and in HPC there are many computing nodes, so number of you can have multiple thread and hence it is faster. So multiple thread is we are doing same work but in different by separating it. But single threaded operation processes are we are doing the same work in one go. Okay, the next topic for this is process control block. What is process? We learn about what is process. What is control block? Okay, we know what a data type. Okay, like say if number is 1 to 7, so we have what this is an integer. Okay, if we have a, so we can say this is a car. And if we have like letter like Sonia, okay, so this is a string. Okay, we have this different data types. So same process have different just we said we see that process also have different data types like PID, username, PR, and I, all these things, time, command, etc. So this set of in which the process is saved is called PCB or process control block. It is a data structure. What is what it is? It is a data structure in which CPU save the process. Okay, it is a data structure to save the information of a process, to save info of process. Okay, now what are the part of this processes? So first is process state. So in PCB, what are the things that is stored in the PCB is first is process state. Process state can be in queue, waiting, or we can say in wait. Okay, running. Okay, or terminated or ended. These are the three process state we have. Next is process ID, which is we just see that PIDs are there. Okay, PIDs are there. Okay, next is your CPU register. Okay, so process is running, but where it is running? Okay, which part because if one CPU register is process 1 is running on CPU register 1, then process 2 can't accumulate this. Now process 2 should know that this is accumulated by process 1 and I have to use some other like 3. Okay, so for this we should know that there must be a process, there must be what register the process is using. So how many register process is using? Register, pointers, I think you know which point to the memory location, pointers. Accumulators are reserved by the process. Okay, this is your CPU register. Next is memory management. Okay, so how much memory or memory location is same in this? Okay, so when process is running on registers, okay, and it's saving the processes somewhere, the that part of the process like 2 plus, let's say one program has 2 plus 2 plus 2 plus 2. Okay, so and program is designed like we give this 2 plus 2 to one register and this 2 plus 2 to other register, and then the sum of this will give to third register. Okay, so this is the um, so here we have 4, here we have 4, and here we have 8. Okay, in this register 4 and 4. Okay, so 4 4 and 8. So this is the C will look this will information register operates only. Okay, this information is saved in memory that this register have value 4, and this information is saved in somewhere memory, this register have 4, and this register will take this information from that memory location and operate on those uh, memories location units, and then will give answer to another memory. So this memory location also saved in the PCB. So which is very important, because registers only say register do not save, register only operates. Okay, so memory location. And the next is process scheduling information. Okay, what is this? Process scheduling info. Okay, what does that mean? It's a checks actually priority levels. Okay, so if you said that if this process is on priority, okay, let's see. If there is a CPU operation or updates are going, okay, and you are watching the same times some series you are watching on your laptop and the updates are going. Now the update will be your priority. If updates there is some error in update, so it will lag your video, not lag the updates to run your series. So that's the priority levels. Okay, so this is this, and next information that is saved in is accounting information. Accounting information means that process is time, what we date and etc. Date is not saved here, which date is it running, but it is saving time. Okay, so we see that we need CPU information, we need memory locations, we need time registers, we need the command. Our CPU are also saving the command we give to run this, and here something virtual and that I don't know what is it about. So it will give the time. So these are the information that is saved in the PCB. First is process state, it is in queue, running or ended. Second is ID, what ID the CPU has given to it. CPU register, where all the calculations are happening. Memory, where the register is saving these calculations. Process and scheduling info, like priority levels, if this will run before or after if some processes have more priority, then it will run first, and then the process who have less priority. And then accounting info like time. Okay, so this is the information run or saved during our process or after our process are ended. Even after this process is saved, because here you see our process of bash is ended long before, but it's still saved. So maybe it's saved for some time. Now next is, what is the operation of the PCB? Now this is the information that PCB saved, but actually what is the operations going that we will study now. Let me change operations. Okay, now first thing is process scheduling. All the process start with process scheduling. Now why I'm saying that? So first thing is, we set the priority of the process, that it is high priority, it is mid priority, or it is low priority. So on that basis, the OS will decide that when and where this process should be going on. So first thing the OS will read is process scheduling. Now on this basis, process is there, like if there are two or another like process P1, P2 and P3. Okay, so it has high priority, it has low priority, and it has very mid priority. So CPU will align the process like P1, P2 and P3. Okay, so this is the way of execution. So it helps CPU to queue the processes. Next thing is memory management. When CPU know about the processing scheduling, then it start memory management. Okay, what is memory management? I already told you that everything is saved in every data is stored in memories. So the PCB contains some of the memory allocation where its data is stored. Okay, so second thing is done by the OS is giving the memory location, saving the memory location where does the data store and will store in the future for this process. Now, process synchronization. Next operation which occurred during this processes is process. I will refer process with P, and let's write synchronization. Okay. So what is synchronization? Synchronization, we all know that sync and two processes are in sync, and communication. That if process are talking to each other or talking to the CPU, that all come there after the memory management. After memory management, process synchronize. That means process synchronize with each other. Okay, what are the dependency on which this process is depends on? Okay, so everything will synchronize together so that there will be no interruption in future. Okay, also communication, they communicate between, there will be time message passing when processes are talking to each other, and process can also talk to CPU as well, GPU as well. So communication and synchronization is the process after memory management. And then we have error handling. Sometimes if process stop during the if there is some halt, or there is some, you give some input and to stop the process, or you give the process is going on but you give some input and the process stop to take that input and then again working on it. So that is called error handling. So this error handling status and error is also saved in PCB for future references. Okay, so this is total this is the operations which happened during the process. Now there's the one thing that is very important in this. It is context switching. What is context switching exactly? Context switching, actually when CPU put a process in a queue, like this is P1, this is P2, this is P3. It's not like when first P1 is fully completed, then only P2 will start, and P2 is fully completed, then P3 will start. No, it's not like that. What actually happened is this is P1, okay, and this is P2, and this is P3. We will study the algorithm on how all this happen, but and this is CPU. Okay, so it happens like that when P1 goes to the CPU and it complete some part of the P1. Okay, then P1 executed, some part of the P1 is executed, but most of the P1 is left, like this one is executed and then left. Then what happened next? Next P2 will go, this part of P2 will go, and this P2 will execute, and then some part of P3 will go, and this part of P3 will execute, and then again some part of P1 will go, and this part of P1 will execute, and so on. Okay, then some part of P2 will go, then some part of P3 will go. That's continuous process. That is the, now the in here process is changing in P2, P1 to P2 to P3. This is the context switching. This is called the context switching. Okay, when the process is one process is CPU take one process and then switch into other to execute. This is called the context switching. Okay, so we can say that CPU jumps into multiple process. CPU jumps into multiple processes This is called the context switching. Now what happened with that if P1 is very big, then P2 is also going with it has some benefits actually, because if P1 is a very long process, then there will be a lot of time that P2 even start. Okay, and if P2 is a very short process, then it really doesn't sense. Okay, so this context switching actually very useful, but let's say it is multitasking. Okay, that what the multitasking is, that we can do multiple tasks at a time. Okay, so it allows CPU to do multiple tasking. Also it handles very well the interruption. Okay, if you, I told you that if some process is going on and you press something and you give the command, then that process will stop, and till you are giving command, next process will come in. Okay, so it's not like CPU is idle. Okay, so OS is very efficient to handle this interruption as well because of this. So it is good in interruption handling. Okay, next is steps. What is the steps of context switching? Okay, so first obviously we discussed the processes stages. Where is, yeah, wait, every process has first new state. Okay, then ready, then run, then terminate. In run state there might be interruption, and it can be wait state, and then if it in wait, it either go to suspend or either go to ready again and then run and terminate. Okay, so this is the state. So let's say any process starts with a new state. Okay, and then it will go to ready. In ready state, what happened? It save the first step should be saves the PCB. Okay, so it first should step of the in the context switching is save the PCB state. Whatever be the process ID, whatever be the memory location, whatever be the counter, whatever be the register saying, and okay, so all these things are saved in the PCB. Next is when this process is going on, this okay, so this is the in ready set, you can say that current. Okay, now if process is run to some part, if some part of the process is run and some is left, then it update the PCB. Okay, now some of the part is obviously run, so some of the memory location is also free, some of the registers are free. Okay, PID may be same or different, we don't know. So all the updated PCB things are saved. Then the other part of the process, then again it moved to queue. Okay, so moved to queue again. Okay, it again waiting for other process to complete to waiting for their chance, and then this process after this then it will run and ready and save this process state is save, and then update after run that this is updated, and then it move to queue. Okay, so this is what PC context switching steps are for this process. Now this one is moved to queue, and that's it will ready and then update and then, but what is the CPU process? It after the process it send like P1 process, it send P1 process to queue, then it will select the PQ process, so it select next second process. Okay, It's load this PCB of the second process, whatever the PCB is saved. Okay, and then start executing other process. Okay, then this process also have some ready state, current state, which is saved, and then it will run, then it update, and then move to queue. But obviously we are saying that if process one, like say this is CPU, and process one is going into the CPU, okay, and it has some PCB, okay, knowledge, and it execute, okay, and it go to P1, let's say 1/4 of it is executed, and it has other PCB, its own PCB. Okay, that's it. Now next time when P2 is coming over, then what CPU do, it will update their PCB, and it will load their PCB. Okay, first it will P1 is come, it will execute, it will load, it will update the PCB of this, and then it finished. Then other P2 will come, it will load the PCB of the P2, and it will execute it, and then again update the PCB of P2. Okay, now other process will come, P3, again it will load the PCB of P3. Okay, and then again update the PCB of P3. Okay, now process 1 comes again, second time, again it will load the PCB and then update the PCB. Now this time of loading and uploading the PCB is actually the extra time. It's not it should not be the it is not, the process is not running this time, CPU is not doing any work, it's just loading and updating the data. That is a time overhead, we can say. So context switching is though great, but it gives a little time overhead. Okay, where it is used, okay, so PC, wherever the PCB used, this is used. Or where the PCB used, washing machine. Okay, your laptop is basically a full machine. You can say Turing machine. Okay, it can perform any type of things, any type of calculations. But there are some machine as well which is not Turing machine, but still they are machine and operating on the electronics and some programming as well, like washing machines. Okay, like coolers. Okay, they all have PCBs, but and they have some input and output, and they switch onto it and they update the PCB. Okay, so these type of area, also ATMs, bank ATMs. Okay, they are some of the example of where the PCBs and context switching is used. Now CPU we learn after process context switching. We discuss that the process in the here. After this we discuss the operation. First the process is scheduling. So first is CPU scheduling. We now learning the operations. What is CPU scheduling? It will schedule the process which will come and on. So there are some important terminologies for this. First is arrival time. It's the time when the process come into queue. Okay, it arrives in the ready queue. Okay, now there is a completion time. The time at which the process completes is execution. Okay, complete execution. Okay, then there's a burst time. What is burst time? The time required process time completed for the CPU for the required process. Okay, CPU execution. Now you will say complete execution, and what is the difference between complete execution and CPU execution? Actually, the process is waiting as well. Okay, so we just we know the state of the process is new. Okay, then ready, then run. Okay, and then terminate. Okay, in run it can be also wait, and in wait it can be also suspended. Okay, and in wait it can also go to run, and then it also go to either run or either ready. Okay, so this this is the whole time of the process, but execution time is here. Okay, completion time, or you can say this is completion time, and this is the whole time CPU taking for the process. Now there is another time called turnaround time. Okay, what is turnaround time? Turnaround time actually is the completion time minus arrival time. Okay, now completion time is what? Completion time of in which the time in which time the process is executed, and arrival time is when it the time when it comes to the queue is arrival time, and then when it leaves the termination it is the completion time. So time take from ready to terminate is your turnaround time. Okay, now there is another time, that is waiting time. Now we all know how to calculate the waiting time. The total time minus what? Burst time. Okay, so waiting time is equals to turnaround time. We can write this like turnaround time minus में burst time. Okay, so if this is a process, this is the process timeline. Okay, it's this is your arrival time, at which time it is arriving. Okay, and this is your completion time, at which time it is completed. Okay, and this is your burst time. This is your burst time. Actually, burst is a duration, not an exact time. So this is burst time. उसके बाद then next is turnaround time, that is completion. Sorry, so sorry. This is your turnaround time. Sorry, this is your turn around time. Okay, and in here somewhere processes from ready to CPU execution. So this is your burst time, and this is your waiting time. Okay, so this is your whole picture. So in this we can see one thing. Let me take a new color for this. Okay, so this is a time. Okay, this is also a time. Okay, but all these three is not a time, they are duration. Okay, they are duration of completing a program. So there are two types of scheduling algorithms. Okay, one is preemptive. and other is non-preemptive. Okay, so what is preempting and what is non-preempting? It's totally depends on the which state we are starting. Okay, so the process switches from running state to ready state or from the waiting state to the ready state is called preemptive. Okay, so switching the process, let me check black color here, process switching from running to ready state. Or the waiting to ready state. Okay, however, the process which when it even terminates, okay, the is used or terminates, or when a process switches from running state to waiting state. Oh, okay, so even when the process terminates, either then the process, if process is sorry, okay, so non-primitive scheduling is used when the process terminates, okay, or when a process switches from running state to waiting state. Okay, so in this it can either happen when process terminates or switches from running to waiting state. So preemptive, okay, preemptive is switching from running to ready and waiting to ready. Okay, and non-preemptive is running to waiting state. Okay, so we still again, let's see the what is the diagram of you have a new process, then it will go to new process, then it will go to ready state. Okay, then it will go to run, and then it will terminate. Okay, that's what it is. Now during the run process, it can wait, and from wait it can be suspend. Okay, now for wait it can also go to ready state or directly to run state. Now if running state, you can see if running state to waiting state or the waiting state to ready state, that means, let me do a green one. Okay, now if running to waiting state and waiting to ready state, that is preemptive. Whereas if there is terminates, process terminates, then go to what? Running to waiting state. Waiting to ready state, running to ready state, sorry. If the process is going, wait. If the process is going from ready, waiting to ready state and running to ready state, then it is preemptive. But it is going to run into waiting state, or if after terminates is going to waiting state, then it will said to be a non-preemptive scheduling. Okay, so these are the method of scheduling. Let's see. So scheduling method, or we can say scheduling algorithms. So on the preemptive as well, there is a very big types. So CPU scheduling comes with two types, preemptive and non-preemptive. Okay, now preemptive has four types. Okay, one is priority. Okay, and short remaining job first. Short remaining job first, and longest remaining job first, and round robin. Okay, non-preemptive come with first come first basis. Okay, shortest job first. Okay, longest job first, and highest resolution jobs. Sorry, highest response ratio next. Highest response ratio next. Okay, so these are the four types of each of the algorithms. Priority, short remaining job first, longest remaining job first, round robin, first come first basis, shortest job first, longest job first, highest round robin. So I think from this you can understand, obviously the priority will be selected. If the priority is high, then this job will be run first, and priority is low, then this job is run later. This is shortest remaining job first. It means the duration of the job is less, then it will be shortest remaining job will taken first, and longest will, in this it will be longest will taken first. Obviously both have its own disadvantages. Okay, because if there is so many shortest job, then longest job may run, we don't know when. And in this, if the longest jobs are running, then if longest job take 1 or 2 or 2 days maybe, then it will be a problem too. Now round robin is something we have fixed this much. What does the round robin do? It tells CPU to take what round robin does is it tells CPU that give every process a selective time. Like every process have 10 seconds. Okay. Now every process should take 10 seconds. After 10 seconds, another process will run. After 10 seconds, and another process. That's how every process have this time to execute in consecutively. But no one is stopped. So this is quite fair for the processes. Okay, now come here, first come first serve means the process will come first in the queue, will execute first, and the process come later in the queue will execute later. Shortest job first, the time for the completing a job is less, will execute first, and the time completing for the job is last, will be execute first in this. The highest so there is a formula they give, highest response ratio. There's a formula for response ratio. Okay, so what is the formula? That is waiting time plus burst time divided by burst time. So this is the formula for response ratio. Okay, so highest, whatever the value of highest response ratio will execute first, and whatever the value of lowest response ratio will execute next. Okay, so these are some algorithms of scheduling algorithm of CPU. Now other is synchronization. There are many synchronization techniques as well, like mutex, chamfers, and monitors. Okay, so we will discuss two here. What first is what is synchronization? We already discussed. The process needs to synchronize with it one another. I told you that process run in if there is multiple processes running. Okay, so P1, P2, P3. There's one way that CPU should know that now is P1 is coming, so P2 will have to stay, and now is P3 is running, and P2 has to stay, and P1 has to stay back. Apart from that, there is a memory location. Okay, there are so many memory location. Now if P1 is already using that memory location during their execution, now in the second part P2 is some of the P2 part is executing, so we should know that P2 will not take this memory location, it has to take another memory location. Okay, so this type of synchronization is needed in CPUs so that your memory does not your processes run smoothly. So synchronization is nothing, it's like people is talking and they are on the same page, nothing else. Okay, so we will now discuss synchronization. Okay, so there are two type of process basically, independent and cooperative. Independent processes, whatever the processes, it does not depend on others, and cooperative, like two process and three process are depending on each other, and they are running by that dependence. Like if you write that stdio dot h, now the C program has to run this link that so the program and this are linked to each other, so they are not independent. Okay, I guess. So I already told you that what is the need of synchronization processes. So first is inconsistency. Why we are need synchronization? First is inconsistency, or you can say consistency. The process will so that process will be consistent when two or more processes access shared data. Okay, there's a data, okay, like whatever the data, and two processes are accessing that data, shared data. Okay, so there will be consistency that P1 is taking first and the P2 is taking first. Okay, so share data at the same time with proper synchronization. So if there is no proper synchronization, they will conflict. Okay, if this change the data and it has to data the previous it has to use previous data, then there will be a problem and issues in the execution, and the thing we do not achieve what we want to achieve there. So there will be inconsistency in the so we need consistency for synchronization. Next is there is a loss of data. Loss of data how? That if there is a P1, okay, and P2, I told you that 2 into 2 into 2, into 2. Okay, so one process is P1 is 2 into 2, P2 is 2 into 2. Okay, it gives 2 into 2 is 4, and it gives 2 into 2 into 4. Now there is a P3 process. Okay, now P3 process is 4 into 4. Okay, now but P3 says that I will save this data here only. Why will we need another register? This register is no use now. So it will save the data here. Okay, but if P1 is not taking this data for another purpose, we have to execute like 4 into 8, 4 into 8, like P1 into P2. Then this data will be lost if P3 is executing here 8. So this data will be lost. If we want 4 into 8, but we get 8 into 8. So that's the problem, that we can lose data if there will be no synchronization. We should know that first P1 will execute all the processes, then P1 can execute it. You can also understand it like this. Like there is, we can also do it linearly, like 2 into 2 into 2. Okay, and there is a process P1. It gives 2 into 2, and it's the register, sorry, process P1, and this R1 memory unit, and memory it save in RAM. 2 into 2 is 4, and then another RAM is taking, that is this, taking 4 is from here and taking 2 from here. This is also saved in memory somewhere. Okay, so from here. Okay, but if there will be no synchronization, okay, so this data can be lost, or this data can be, another process maybe use it, this value, and this data will be lost. Okay, another, if process the P3 from somewhere else, any other process use this register, use this memory space, so then this data can be 4, apart from 4 this can be 88. Okay, then our reading will be not same. So synchronization is needed for this purpose as well. We show, so why our data will not be lost. Okay, apart from that, there will be a deadlock if 2 or more processes are like, say, if there is P1 and P2, they are a cooperative process, they will run on, if P1 is run fully, then P2 will execute. Okay, whatever be the equation, like you can say 2x square, and x is equals to 2. Okay, so first P1 is gives 2x square, doing x square, it will take data from x here, and it will take equation from here and data from here, and then P2 is depend on P1, that it will, when it will sum, it will multiply the x square, then it will give the answer, that is 2 into my x, whatever be the answer, that is 4. Okay, so it will give it. But if P1 is somehow do not perform, or there is someone other data interrupts in P1, so P2 will also always stay in that position, that is a deadlock. Okay, now there are some synchronization techniques as like mutex, semaphores. In mutex there will be a, like there are some techniques to for synchronization, sorry. Okay, so first one is mutex. In mutex, what it do, it forms a critical section. Okay, any process or any thread, only one thread, one process or one thread can reach that critical section at a time. Okay, so whatever this is a critical section, let's say, and process 1, process 2, process 3, all now process, only one process 1 can execute, can come in the critical section at a time. It will perform their whatever the performance they have to do, and then execute. Now this critical section is empty, and the CPU also know that this process is completed. Now P2 will enter, and this CPU does know that now this process is enter, and it will load their PCB, and hence it will execute, then third process is coming. So mutex is actually making a critical section, and only one thread or one process can enter this critical section. There is another called semaphores. This will very useful actually when you will study later about when you will study multiple programming and CUDA and MPI. This terms will be there in the programming, so I think that is very important as well. I also did not fully understood these terms and all these things, but I'm also revising it. But let's see. Okay, so whatever I understand, I will here to discuss. Now next is semaphores. What is semaphores does? Semaphores actually manage resource allocation, okay, in a controlled manner. They resource means memory or registers, okay. They actually manage those resource allocation to the process, and like P1 is, if P1 is using memory unit of 101, then P2 can't use it, okay, and P2 should use another resource. So that if they are if we have a resource manager, then also the process is synchronized with each other. Okay, so there are many binary semaphores, counting semaphores, but I don't think that deep I have to go. And then there are one thing, can say message passing. Okay, wait. There's one thing called message passing. What's message passing? Actually, in this case, instead of CPU talking to each process, processes are talking to each other. Okay, so there is a shared memory, you can say. So even in parallel programming, you will learn two types of programming, with shared memory and with not shared memory. Okay, so some processes who have shared memory, it's use different language and different library, and if the memory is not shared, then a different library. So in message passing, that we also have MPI. We will learn message passing for C++, and in this the memory is shared. Okay, so if memory is shared, and the processes will talk to this shared memory, and this process will respond to this shared memory, and then in somehow how the process is talking to each other. Okay, one process can send data and one other can receive data from other, and in that way the process can talk to each other, and then there will be a synchronization as well. And there are also these are important topics that I am discussing, because these methods can be used later. One is barrier synchronization. So in this mutex, we have a critical section. Okay. But in barrier, we have a barrier. Like if processes come here, if like process P1 is here, process P2 is here, and process P3 here. Till process P1, P2, and P3 all come to barrier, the processes P1 is stopped. Okay. So this is called the barrier synchronization, and this will be used in later section as well when we learn the parallel programming, and this is the part of your programming. So when all the part of this P1 and P2 and P3 reach the barrier, then they will start again to execute. Okay, so this is also a way to synchronize section. And then the next thing is memory management. This is the most tough thing and for me. But I will try to make it simple for me and for you too. So memory management is a little. So basically, memory management. Why do you need memory management? Memory management is the most important thing, because why your laptop lag? Because there isn't enough memory. If memory management is good, it can even the if memory management is good, even the heaviest work can be done efficiently. If management is bad, even the shortest uh, program is done very badly. So that's memory management is very important. It's crucial for everything is we learn about is crucial for OS, but this is a little difficult, I guess. Yeah. So every program, every processes, every thread use memory. Okay, and memory is nothing just a space. It's random. There is two type of memory: random access memory and the hard drive. You, if you have a laptop, you will know that RAM and hard drive are the disk memory are two things. RAM is a volatile memory. Hard disk is your memory. Okay, so most of the thread thing is done in the RAM or volatile memory, and when the process but this is volatile, obviously. So we have some solution where this two talks with each other, and our memory management is more efficient, some more efficient and yeah, more efficient. So basically, whatever the memory management we are talking in this is the memory management of the main memory. Main memory means RAM. Okay. So what are we talking about is main memory. Main memory is a RAM. So, so there are two types of addresses in the main memory. One is logical and one is physical. Physical addresses, as the physical addresses are the memory unit, like whatever with the memory unit address, this is the physical address. So, okay, so and whereas the logical address is generated by CPU. Okay, it is a virtual address somehow, and it saves the size of the process. Okay, so it generated by CPU. Okay, and it is virtual in nature, and it saves the size of process. Okay, or this address can be changed for process. So these are about the logical processes. Okay. Yeah. So now what is physical process? Physical processes, physical address, sorry, this not processes, these are addresses. Okay. So logical address is generated by CPU, it's virtual, it saves the size of the process. Actually, this is not a address space, it's just looks like an address space. Okay, so it saves the process size. Physical address is the space, is the actual address of the memory unit, whatever the address of the in the RAM. Okay, so it's then actual address of the memory unit. Okay, so whenever the processes run, the memory load that address register to the CPU load that address register. So what happen is that CPU has some logical address. CPU have some logical address and this logical address point to some physical address, okay, in the memory unit. Okay, so like logical address is the like 1238, 1238, and it will pointing to the register of physical address, and then this register, we can say not physical address, actually register, and this register is pointing to physical address in the memory unit. So you can scan. Wait, CPU is pointing to registers, okay, and registers is pointing to memory unit, memory management unit. So it is the whatever the CPU has the size, or whatever the address CPU has its physical address, sorry, logical address, and through registers what have they have physical address, and they point to the memory unit physical addresses. Okay. Now the addresses we know. Now after we know the addresses, there is the process called loading and linking. So we all know about Thingai. If you are a computer science student, I was not. So loading and linking happens even during your when you execute your program. You have different modules. Okay. So modules are loaded and then linked with your program file and then execute. So these are the loading and linking thing are same thing basically. So there are two type of loading and two type of linking. Right. Loading and linking. Okay, so there are two types of loading and two types of linking. First is static and one is dynamic. What is static? Static load the entire program at a time. Okay, so it loads entire program. Okay, what dynamic do? It do not load the entire program. It's loads in whatever the needed. It load whatever the needed and then load the other part when they need. You can assume that if we have x is equals to let's we have a program like x is equals to 2y, okay, and we have dot use math.h. Okay, so it will load that directory. Now we have something like a is equals to something, then it will load the alag directory, input output whatever. Okay, so entire program is loaded at the first time. So in this entire program is loaded into a fixed address. Okay, entire program is loaded into a fixed address. Also, it requires more memory because why? Because all the program is loaded at a time. Okay, whereas in dynamic loading, all data of a process must be in physical memory for the process to execute it. Physical memory we already know. What is physical memory? That's physical memory, RAM. Okay. Now the size of the process is limited to the size of the physical memory. To gain proper memory utilization, dynamic loading is used. In dynamic loading, a routine is not loaded until it is called. All routines are residing on a disk in a relocated load format. One of the disadvantages of the dynamic loading is that unused routine is never loaded. This loading is useful and a large amount of code is needed to handle it efficiently. So we already discussed that if math.h is needed, it will be loaded. If io input dot stdio dot is needed, then it will import, then it will be loaded. So all the files, all the modules are loaded in main memory. Okay, and it loaded all the modules are exist in main memory, and when you load it, okay, it does not load until it will not need, or until it is not called, until it is not called. So for large number of program, it is very efficient, because instead of we are loading all the program at once, it is loading the part of it. But if the module which is never be needed, it can never be loaded. Okay. Now static and linking also have two parts, static and dynamic linking. This is also have dynamic. Sorry. This is also have two part, dynamic and the static linking. Okay, so like that, it is also all the necessary program module into a single executable program. So this linker combines all necessary modules in single executable form. .exe, okay, executable form. Whereas in dynamic memory, it stub is included. There is a term called stub. Okay, it is included for each appropriate library, routine, or reference. Stub is actually a small piece of code. When stub is executed, it checks whether the needed routine is already in memory or not. If not available, then the program loads the routine into the memory. Okay. So dynamic linking, like the dynamic loading, it does not link all the data. It made a file called stub. It's a program. What it will do, it check if the program is in main memory. If it is, then it will link. If not, it will fetch that data, load the data from the dynamic memory, from the physical memory, and then link it. Okay, so it does not link all the data at once. So this is about linking and loading. Then there are things called swapping in which operating system and RAM are talking with each other, like GPU and RAM are talking with each other, and when this process is needed, then it will swap, and then when resources are not needed, it will not swap. Okay, so these are swapping things. It's not. So, like if you have an like swapping, what happened with swapping? Actually, you have a main memory, you have a secondary memory like hard disk. Okay, so the data is in hard disk. You don't need to load the data in memory. And swapping, what will do? Swapping will actually fetch the data, whatever data is loaded, and then give it to the CPU, operating system. Okay, then whatever the data is swapped, it will used by the CPU, and if data is not needed anymore, it's swapped back to the secondary memory. So this is swapping process. This is also very efficient for memory management. There are also some memory management techniques like contiguous memory location or non-contiguous. Memory management has actually one is uniprogramming, whatever programming you are doing right now. So uniprogramming, and there is multiprogram, which we will learn later. Okay. So multi-programming has some memory management techniques, like there is contagious memory location, contagious memory allocation, and non-contagious memory allocation. Allocation. Okay, so it also have two types, single and partition. Also have two types, and it also have two types. It has one paged memory allocation and segmented memory. Okay, and it has segmented memory management. And it has also two types, single and partition. Partition. Okay, so these are the memory allocation techniques, memory management techniques. Okay, so uniprogramming, multiprogramming had two types, contagious and non-contagious memory allocations. Contagious memory allocation is single contagious allocation or partition contagious allocation, and whereas the non-contagious has paged memory management and segmented memory management. We will study about all, and if I was wrong, so uniprogramming, we all know one after the other the process are doing. Multiprogramming, we know that multiple processes will run at the same time. So what is difference between contagious and non-contagious memory allocations? So contagious memory allocation is a memory management method where each process is given a single contagious block. So actually there are two type of so basically, these memory allocation techniques are divided in two very simple thing, that is uh, memory allocation. Okay, on this, so it will give a block of memory like this whole set. This is yours. Okay, if any program wants memory, it gives it a block of memory. Okay, 1, 2, 3, 4, 5, 6, 7. This type of contagious memory allocation. Whereas in this, it will not give a block of memory. It will run the program that will not need a block of memory space. Like it will give 1 and then give 5 and then give 7. So it gives memory space, but not a block. Okay, it gives random memory spaces. Okay, now what is single and partitioned memory management techniques? Now in single, as we know that in single we know there's a single type of thing and there will be a partition in the block of and there will be a single block and there will be a partition in the block. Okay, so it will in this it divide the memory into fixed sizes, and then this fixed sizes will given to the program. It is also of two types, fixed and dynamic. Okay, in fixed size, that the size is fixed, memory allocation partition, but size is fixed. Okay, like say this is the memory, this is the block it assigned to, and it gives the partition of the block, but each size of the block is same. Like it also have 4 blocks, it also have 4 blocks, it also has. But in dynamic, it is not like that. It gives the space according to the usage. So it can be 5, it can be 1, it can be 2, and it's anytime. Okay. And in paged and segmented memory, this is little. So in paging, what is paging is in this paging, actually CPU formed actually what is the pages is let's say there's a RAM, there is a RAM, and there's a secondary memory like hard disk. Okay, so inform all the information we have is in hard disk because RAM is volatile. Okay, so information, whatever the information we have in the hard disk, and RAM load that information, it stored them in the form of pages. And RAM CPU make a table of these pages, like this page one, its location, page two, its location, and whenever the CPU execute, it will go what information it wants. It wants this information, it will see the address space, it go to the address space and fetch that information. So that's how paging works. Okay. So this is the pages. Okay. So pages is nothing the program, whatever the we had know that this non-contagious memory is stored in the this way, and programs, but to store it in this way we have to break the program. Okay, so program is baked into pages. Okay, and wherever the pages there is a page data sheet is mentioned, maintained by the page number and the page number and memory location. There is something, there is some formula, and then when the program is run, and then other page number, then they go to their associated address space, then this will execute, and then this program point to another page, and then this points to the address, then this will run, and that's how it will done. But in segmented thing, the program is not break into pages like this. It breaks on the it divides program is divide into the like arrays, functions, okay, functions and etc. Like if program will understand that there is a some function, okay, this part of function is run simultaneously, and then and save this part in one memory location, and then when part is that function is ended, then it saved other memory in the uh, other part of the program in other location, and then till when this array or something structure or function or data structure is completed, and then it save other part in the other memory location. That is the segmentation. So it is segmentation. It's doing segmentation, whereas it's making pages of the memory location. Okay, so now the topic we have is file systems. Now this is the practical thing we getting out of the notebooks in this. So what is Linux file system? Okay, so Linux has different file system. Basically, every Linux, we already see that in the practical session we had, that every Linux start with this root. Okay, and in root there is this is the slash where it all started, and then we have root. From there, and this folder we have home, and in this folder we have bin. These are the three folders we have in this address space. And in home we have users, multiple users. Okay, in home we have user one. We actually saw that user one, user two. Okay, let's see that practically if you forgot. Let's say this. Okay, so here you see we have a tilde here. Okay, so tilde means we are in our for user space. Okay, if we do cd, that's we going out into the previous folder, then enter, and there you see 4. So all the users are saved into home, and if we go cd and press the previous folder and we go here. Okay, so there is the first directory. From there we have a home, and then home has users. So if we say cd, okay, we go in this and we do ls. We have our user. We have only one user right now, that is Neha. Okay, so this is the file system of the Linux. Now, apart from this, Linux, what type of file or extension is used in the Linux? So it is extension 2, 3, 4 and XFS. So Linux used extension 2, 3, 4 and XFS. So whatever this extension are, this gives us the access and thing we can do in our document. So first is your extension 1, ext1, which is called extension 1, extended 1. Okay. So in this type of file, this comes in 1992, and we can make the file, but there will be no journaling, no symbolic links. Maximum file size for this is 2 byte, 2 gigabytes. Sorry, you cannot be exceed from that, and no extended attributes are there. Then there come ext2. Okay, it come in 1993. It comes with extra features, which is file permission. This is its feature. It has a file permission. We can permit file to each other. We can save. It means that if you have some file, you can change the permission that another person can execute it and write it on. We will see it later. Okay, large file size will be larger than extension 1. Okay, we have more files. Okay, so this is our file systems we operated on which the Linux is operated, and online resizing of the file we can do, and there are more features. I will share the document which it is. If you want it, if you want, I can share the document. So my notes. Sorry. Yes, then comes extended 3, and it comes in 2001. Okay, and its main feature is we can journal file system. Right. Okay. Yeah. larger file, we can maintain larger file sizes increases, and we can maintain larger file at bottom. That's it. And then comes ext4 in 2008, and in this we can maintain 16 terabyte of file size. Okay, and the volume supports are also big. Online defragmentation are there, delayed allocation. We can encrypt our file, and there are some features to this. Then comes the XFS. Okay, so it is 64-bit journal in file system. Okay, so large it is released in 1994. It can use 8 EB of files. Scalability, you can scale the file here. Online resizing, advanced features. Now next is how we can see those files and permission and of the files and directory. Next part is file and directory permissions. Okay, before going to permission, let's see one thing. Okay, we did ls into l, and we have this. So this is our folder is open. So this is showing only for Sneha that we have this. You are noticing here drwx this rx7 Sneha 4096. This told us the file permission, who has the read, write, and x means execute permission. So in this directory, only me, Sneha, has the read, write, and execute permission, and the group has nothing, and the other user has read and execute permission. So this is Sneha 2096. Okay, now let's say ls, sorry, cd as. Okay, now we enter into our directory and we will give the same command ls. Now see, this is the command these are the files we made in the last class: condition.sh, loop.sh, until.sh, while.sh. Okay, and these are the permissions set for it. See, this is if it started with dash, then it is a file, and if it started with D, then it is a directory. Directory means it is a folder. Okay, and that it is started with dash, then also in folder and in file there is a permission. So R means read, W means write, and X means execute. Okay, so so this comes with here. So file permission comes with three types of people have this. One is user, then group, then others. Okay, so for user there is write, read, and execute permission. For group as well there is read, write, and execute permission. For others as well, read, write, and execute. Okay, so user, we are the user. If there's a company who made group and they're in that group they add multiple users, so they can, this is called group. And any random users can, if any other random user can access this file, then the permissions happens. Okay, now this is the read, write, and permission. Read means it can read it, write means it can change that file, and execute means it can bash. We will know that bash command, through the bash command we are executing the file. So this is used for that. So read, write, and execute are the three commands. Now in the Linux system, basically, this command has some numbers. On that number basis, we can, let's first see one command. So you see, like there is a command ch sorry, for this, we have to go sudo ch okay, and then we will type file name. There is some. So with this, we can read. So, so okay. And this also apply on folders and files. Okay, so in folder, read, write, and execute means you can actually read the data, read the listing, ls command, you can read the listing of the directory, and you have permission to create. You have permission to create, to delete, and to rename. Delete. For write in folder, we have the permission to create, delete, and rename folder. Okay. In that directory. And with execute, we have the permission to change in the directory. Okay, use the unintegrated form of the path of the file. We can change the path of the file in the directory. Okay. Now, for file, R, W, X has different meaning. For file, we can have the condition to read the stored data. Thus, we can read the stored data. In thus, we can update the data, whatever written in the file, overwrite it, and in that we can run the file. Okay. So these are the two types of permissions we can have. The three types of permission in two ways. Okay. Now each permission here you are seeing that we have three type of. That's why we have dash, we have RW, we have dash. Sorry, we have RW accept, obviously by user have a. Then we have R, then we have dash dash, then we have RW dash. So if this means, what that means is user, this is for user, this is for group, and this is for yes, others. Okay, so that means user have read permission, write permission, and execute permission, and group only have read permission, and others have read permission and write permission, but not the execute permission. Okay, so that type of permission is showed in here. So you can see this is read, write, but not execute permission. This is read permission, but not write. This is for your user, this is for your group, and this is for your others. Okay. Now, we understand how this permission is allotted. But now, if we want to change the permission, okay, we want to change it. We want to change it. We want to give group a permission to execute. Okay, so how we will give that? So that is done by a command. But before command, what is the mathematics? So Linux, what the Linux do? It gives the number for each part of the permission. Like for read, we have a number 4. For write, we have a number 2, and for execute, we have 1. Okay. Now, if the number is 7, 4 plus 2 plus 1, sorry. So then it have all conditions. Okay. Now, if number is like say 6, so we know 4 plus 2 is 6. Then we know that it has only read and write permission. Now, if number is 5, then it has read and execute permission. And if number is 4 only, then it have only read permission. So by changing this number, we can give permission to other user. Okay, how will we change this number? By using the command like sudo ch mode. Okay, this is the mode. Okay, now let's say condition have only we will give all the 7 to our. This is now 4 plus 1. 4 plus 2 is 6. We're giving them 7. Okay, and giving group also 7. Let group give read and write permission. The 4 plus 2 is 6. And for them, we giving the read and execute permission. The 4 plus 1 is 5. And then we give condition such. And now, so it asking for password. And we will type the password. Okay. So it changed. Okay. Now we will do again LSL. Now you see the permission is changed. WX we have, here we have RW and we have RX. So that's how you can change the permission for group for your this number belongs to first number belongs to user, second belongs to group, and third belongs to the others. Class is over here. Okay. So now we learned file system, we learned the operating system, we learned the memory management, we did most of the thing that was needed in this class and what I learned in the CDAC at the acc-hpc course. So let's go through first what we had learned. So what we learned that first is what is Linux? It is a OS system. It's kernel, shell, and application, 3 layers. Application, there are software run. Shell is where are commands, and kernel is the hardware. Okay. We can run Linux in Windows by 2 ways, WSL and virtual machine. In this class, we are doing WSL, but in CDAC course, we may be using virtual machines. This is easy too. You have to download like CentOS. That's something. They are a virtual machine. They will run. They will take some of your resources and they will run Linux on that resources. And then we see this username and post name, and then this is address, and then we type a command. We learn some basic commands like pwd, cd, ls, page up, page down. These are the navigation thing. And then we learn shell scripting. Shell scripting, we give command to the shell. We learn some commands with that we give in the shell that pwd, cd, ls, touch, cp, mv, grab, echo. And apart from that, we learn about if, else, for, while, loop, and case. If statements, this is the syntax for if statement. There are this syntax for while, and this is the syntax for until. And then we learn about the processes, what are processes, what are the states and stages of the processes, how to see processes, running processes, and how to kill the running processes. And then we see the types, the processes like user, system, foreground, background, batch, interactive, etc. We see parent, child, zombie, orphan processes, and then we see unithread and multi-thread processes. And we see them, the process control book, how processes are saved in the OS, and what are the things that save for the process in the OS. Then we see how the process will
operated, and in that we see process scheduling, memory management, synchronization, and error handling. Then we come to the topic of context switching. Context switching is nothing but how we change, how one process changes into another at the time of CPU management. So CPU jumps into multiple processes. It's a context switching. Then we see some, we go from that for the process scheduling. Then we see the CPU scheduling. So there are terms, arrive time, completion time, burst time, turnaround time, and waiting time for the CPU scheduling. Then we have simple algorithms for scheduling. There are two types of algorithms, primitive and non-primitive. They both depends on which state, from which state to which state we are going. If we are going to ready, from run to wait and ready to wait, then it is preemptive wherever. If we're going to run, sorry, if we are going to ready state from whichever state, either it's run or wait, then it is preemptive. If it's going from to wait state from run to terminate, then it is a non-preemptive. Now CPU has algorithm for both preemptive and non-preemptive. We discuss some of this algorithm: priority, shortest remaining job first, longest remaining job first, round robin, first come first serve, shortest job first, longest job first, highest response ratio next. Then we see synchronization, independent and cooperative, lead sync and need synchronization. For why we need synchronization, consistency, loss of data, and deadlock of the memory management. Then we need synchronization technique. For synchronization, we study that mutex that will take a critical zone in the and one process, only one process at a time can enter this critical zone. We take the semaphores. Semaphores, what they do, they manage the resources to the processes, in message passing processes are talking to each other through shared resources barrier. One process cannot cross the barrier until all the processes reach the barrier. And then we see memory management, logical and physical address. Logical address is generated by CPU, and it saves the size of the processes, and it can be changed. Whereas physical address is the actual location of the it is the actual location in the memory unit, and CPU load CPU actually saves the logical address, and the logical address is pointing towards the register, and register pointing towards the memory unit where the physical address is saved. Now there is two types of thing that comes into the memory management, that is loading and linking. Loading has two types, static and dynamic. Dynamic static loading has a tab program into a fixed it to load the entire program into a fixed address at a time, all the program. And dynamic loading, the program is loaded until it is called. When it is called, then it will load in the main memory. And in linking as well, same, that if it links only in static linking, it links the module, all the necessary module at one time, and it made an executive file for it. Whereas in dynamic linking, we have a stub type of creator program that will manage the loading, and it load only that type of it link it whatever the program is needed, it load it and then link it. Then we learn about the swapping. In this, nothing, our data is saved in the secondary memory. There is no data in the main memory, like previously we discussed. And memory unit is swap data from the secondary memory, and then CPU loaded. And then when the task is completed, the memory location is free, and the data is swapped again in the secondary memory after the running. Then there is memory management techniques. One is uniprogramming, one is multi-programming. Uniprogramming, we all know. Multi-programming has two types of memory management, that is contagious and non-contagious. Non-contagious memory assign a block of address space to the program, whereas non-contagious memory will save some part of the program in some memory, and then save the program in parts. Okay, non-contagious memory location has two types: single and partition. Single memory, single we know it saves the block, and wherein partition it part the whatever the block is assigned, it part that block into some parts so that memory can be saved efficiently. Even this partition have two types: fixed and dynamic. Fixed shape has like the memory is parted into a fixed distribution, whereas in dynamic it parted into a different thing. Now there are non-contiguous memory allocation, in which we have paged and segmented. In page, the programs break into pages. There is nothing related to where the program is ended and where it is started. It's just saved in the pages, and that pages location is saved. There is a page table made by the CPU or OS system, where and pages address and pages number are saved in that table, and whenever the CPU need that program, it call that it from the pages. And segmented, actually it segmentation, it is segment the whole program into arrays, functions, and data structures. So it will easy to call the function. It all one function is saved in on one location, another in the other location, so it will be more efficient. Now we have studied about Linux file system. Linux file system has this directory, and then from this directory we have three directory: root, home, and bin. And in home we have all the users, and we have this type of family: extension 1, 2, 3, and 4, and XFS. Then in file and directory permission we have user, group, and others. And we have three type of permission: read, write, and execute. Uh, in file and directory system, we have user, groups, and other. We have three type of permission: read, write, and execute. And for user we have read, write, and execute. For group we have read, write, and execute, and others we have read, write, and execute. Now two types of permission we need for folder and for files. For folders, R means you can list the directory. W means you can create, delete, and rename the directory. And execute means you can change the path of the file. And the files, whereas read means you can read it, W means you can update and append and whatever you can do, and X means you can run in the bash command. Now whatever be the in the command shell, we see the permission like this. If there is a file, there is dash. If there is a directory, there is D. So this is written in like RWX, RWW, RWW. First is for user, second is for group, and other. Third is for others. So this means user have read, write, and execute permission, whereas group has only read permission, and other have only read and write permission. For changing the permission, we need to understand the mode of this. For read we have 4, for write we have 2, and for execute we have 1. When we add this, we have 4, 2 plus 1. It means if someone has mode of 7, that it means it has all permission. Whereas in 6 we have read and write permission. Whereas 5 we have read and execute permission, and for 4 only read permission. So this is the all what we understand and what we learn in this Linux class. I hope you understand. Stuff like ये क्या हुआ तुम्हारी मदद करेगी